Welcome again. We are not here today merely to deliver a presentation on waste management. We are here to discuss the evolution of the food engineering discipline, transforming from a reactive problem solver into a proactive sustainability designer. Our title might seem a bit long, however, the subtext is crystal clear. We have a massive goal to reduce food waste by half by 2030, and we cannot achieve this simply by sorting trash. If food waste were a country, it would be the world's third largest emitter of greenhouse gases after China and the USA. Can you imagine? The food we produce but don't eat is working harder to heat the planet than we are. In this presentation, we will address the concrete, technical and innovative solutions that food engineers can bring to the table in line with the EU Green Deal and Turkey's zero waste goals. We will navigate through a wide spectrum ranging from eco-friendly packaging to the root-to-stock menu designs and upcycling prototypes that transform waste into raw material. Our slogan, reduce waste, increase value, will not just be a wish, but the fundamental axiom of our engineering design. If you are ready, let's start building the food system of the future together. The training model is designed to provide food engineers and industry managers with a strategic vision in alignment with the European Union's goals of reducing food waste by 50% by 2030. The course offers a holistic approach that covers not only technical implementation process but also legislative synchronization between the EU Green Deal and Turkey's zero waste regulation. Participants will learn to design eco-friendly packaging using circular economy models, implement sustainable menu engineering in the HoReCa sector, and transform industrial side streams into value-added product prototypes. The training aims to empower professionals with the autonomy to manage complex sustainability processes independently. By the end of this module, participants will be able to legislative analysis, circular design, sustainable operations, upcycling, and strategic competence. We can start with this reduce waste, increase value. So who will manage this transformation? Of course, us, food engineers and sector professionals. However, knowing only thermodynamics or microbiology is no longer enough. The Green Comp European Sustainability Competence Framework, developed by the European Union, assigns us a new role. Sustainability is no longer a department name, it's a competence that every engineer must possess. Green Comp is built on four fundamental pillars. First, embodying values. We must see nature not just as a resource depot to be exploited, but as the most important stakeholder at the table. Second, embracing complexity. To food system, it's not linear, it's a complex web. Being able to product what will break in logistics when you change your package is exactly what we call systems thinking. Third, envisioning futures. Solving current problems is not enough. We must be able to imagine scenarios where waste is never generated. And finally, acting for sustainability. We are talking about an engineer profile who doesn't stay in the lab, but influence political processes and force change. We need professionals who question not only how it's done, but why it's done, combining technical knowledge with a green attitude. Remember, sustainability is not a choice, it's a mandatory competence for survival. Now let's talk about the boring but vital part, legislation. Don't worry, I won't put you to sleep with legal article. However, we must know this legislation is the greatest trigger for innovation. The EU's Farm to Fork strategy is not just a list of recommendations. It set binding waste reduction targets for 2030, such as 30% in retail and 10% in production. So the era of it will be nice if we reduce it, it's over. The era of you must reduce it has begun. On the Turkey side, the zero waste regulation and GECAP mechanism have activated the polluter pays principle. This means you pay the price for every plastic package you produce. This forces companies toward designs that generate less waste. The most critical point is the EU's new packaging regulation. For exporting firms, requirements such as all packaging being recyclable by 2030 and the use of 30% recycled content are coming. Turkey's regulation on recycled plastic in contact with food coming into effect in November 2026 is the keystone of this alignment. In short, those who do not comply with the legislation will fall out of the game. We should see this rule not as an obstacle, but as opportunities to create competitive advantage. Let's move on to packaging. Everyone is obsessed with bioplastics. We say let it be biodegradable, let it disappear in nature, but the reality is not that simple. As food engineers, we must act with data, not emotions. There is where life cycle assessment comes into play. Life cycle assessment data present us with an interesting bioplastic paradox. Yes, the production of bioplastics like PLA may emit 73% less carbon than fossil plastics. Great, but where do you throw this package? If the industrial composting infrastructure is insufficient, as it's in Turkey, and you send this PLA package to a regular landfill, it releases methane gas while decomposing in an anaerobic environment. Methane is the greenhouse gases 28 times more potent than carbon dioxide. So we are doing more harm than good. Therefore, if we don't have to infrastructure 100% recyclable PET bottle can sometimes be more eco-friendly than a package labeled bio. Conducting a realistic scenario analysis when designing is a requirement of engineering ethics. We must focus not just on the label, but on the journal of the waste. So if we can't completely eliminate packaging, why not eat it? It sounds crazy, but nature has been doing this for millions of years. An apple peel is a perfect package. In engineering, we are turning towards biomimetic designs, edible films and coatings. By using polysaccharide, protein, especially whey protein, and lipid-based coatings, we can extend the shelf life of products like cucumber or apples. Considering that post-harvest loss in Turkey is around 35%, this technology is revolutionary. A fantastic example from the world, London-based Natpla. The capsules they produce from seaweed. You may have seen them in marathons. Runners pop this capsule into their mouth to hydrate instead of carrying water bottles. You can eat the packaging, or if you don't, it disappears in nature in 4 or 6 weeks, just like a fruit peel. It's also used for ketchup package. Another technology is mycelium. By feeding agricultural waste to mushroom roots. We grow packaging that is shock absorbent like styrofoam foam, but fully home compostable. We don't manufacture, we grow. This is what innovation looks like. Let's transition to the HoReCa sector, meaning restaurants and hotels. The magic phrase here is root to store cooking. We used to throw away broccoli stalks or carrots, greens. Now chefs and engineers are making them the stars of the menu. Pickles from broccoli stalks, pesto from carrot greens. This is not only an environmentally friendly approach, but also an economic strategy that reduces costs by bringing raw material efficiency close to 100%. In addition, we must conduct data-driven menu design. The water footprint of main dishes, approximately 1,000 liters, is 6 times higher than that of a soup or beverage. Turkey is a tea country. The carbon footprint of a cup of local tea is 30 times lower than imported coffee. Highlighting local tea on the menu provides a massive carbon saving with a simple green notch. We are also updating our menu metrics. We are cutting waste at the source by removing dishes in the DAX category from the menu. Theory is good, but practice is everything. Who in the world is doing this right? Our first stop is in Berlin, Freya restaurant, the world's first vegan zero waste restaurant. Freya has no trash cans. Yes, you heard that right. Products arrive from suppliers in crates. There is no plastic. Any organic waste generated in the kitchen is thrown into an on-site composting machine. Within 24 hours, this waste turns into soil-improving fertilizer, and it is sent back to the farmers from whom the restaurant buys vegetables. A complete circular economy masterpiece. Our second stop is the Netherlands in stock. Sorry for my pronunciation. I don't know the correct pronunciation for the name of restaurant. They are doing food rescue logistics. They collect ugly vegetables that cannot enter the supermarket due to shape defects and unsold bread. They process them in their food rescue centers and sell them to chefs. Not stopping there, they produce potato beer from rescued potatoes and Bamidjes beer from waste bread, transforming waste into a branded cool product. Here is the magnificent dance of marketing and engineering. Now let's put on lab coats and talk a bit about upcycling, our first prototype whey. Turkey is a dairy country and we produce tons of whey. Pouring this into the environment is a major crime due to the high lactose content. For an engineer, this is not waste, it's a free carbon source. The process is as follows. First, we recover the valuable proteins via ultrafiltration. This become sports nutrition. We ferment the remaining lactose-rich liquid with a special yeast. Why not normal bakery yeast? Because it cannot eat lactose. This yeast can. The result, ethanol. You can distill this to make whey vodka or blend it with fruit juice to produce low-alcohol fermented beverages. Alchemy that transforms waste treatment costs into a revenue stream. Our second prototype addresses, unfortunately, a bleeding wound in Turkey: bread waste. 12 million loaves of bread go to the trash daily. This figure is terrifying, but for a beer producer it's an opportunity. Bread and beer are historically cousins. Both consist of grain, water, and yeast. With the toast ale model, we collect stale bread, dry it, and grind it. We substitute 30% to 50% of the barley malt used in beer making with this bread crumbs. During mashing, the enzymes in the malt convert the starch into bread into sugar. You save on malt cost and give wasted bread a second life. Our third prototype, the son of the Mediterranean, citrus peels. Thousands of tons of peel waste are generated into fruit juice industry. We process these peels with the Aspergillus niger mold using a method called solid-state fermentation, which involves low water content. This mold breaks down to pectin on the peels and produces pectinase, an enzyme with high industrial value. Furthermore, the remaining pulp becomes excellent animal feed enriched in protein, killing two birds with one stone again. Looking at commercial success story, Danish grain turns spent grain into flour using a patented method. Pasta and crackers are made from this flour, which is high in fiber and protein. Another example, Austrian Kerntech goes even further, processing apricot and cherry pits. They technologically remove the cyanide risk inside the kernel and produce milk alternatives and oil from it. It consumes 90% less water than almond milk because the apricot is already irrigated for its fruit. The kernel is free. I can hear you saying the ideas are great, but where is the money? Green transformation is an expensive investment, but fortunately funding sources are more abundant now than ever before. In Europe, the Eurozone Euro program, especially under the Farm to Fork heading, distribute massive grants. If you have a large-scale R&D project, you can receive a grant between 70% and 100%. In Turkey, the TÜBİTAK 1832 industry green transformation called World Bank supported program stands out. It's very suitable for waste recovery machinery or prototype commercialization. Additionally, the Ministry of Trade's responsible program support our exporters Green Deal compliance consultancy with a 50% grant. The money is on the table. The important thing is to present the right project to the right fund. We have reached the end of the road, but actually it is just the beginning. We have a clear roadmap ahead to reach the 2030 targets. First, digitalizations. Two, second, infrastructure, and third, human resource. Converting Turkey's annual 23 million tons of food waste into economic and environmental gain is in your hand. Thank you for listening.